Okay, the next one right here is a little bit more challenging, but we're going to do the same thing. We're going to plug in negative x into the function, and we're going to see what happens. So it'd be negative x minus 1 over negative x. Now let's simplify this. Double negatives go positive, and so I can get rid of this. And then let's factor out a negative 1 because that gives me x minus 1 over x, which is the original function right here. So then I can write this as negative f of x. Negative 1 times f of x, or just negative f of x. So that means it's obviously odd because we plugged in f of negative x, or we plugged in negative x in for f, and we got the opposite, the original function back, which means it's odd. Okay, trig functions might seem difficult, but they're really not because I can write this as 1 over cosine of x, and I can write this as sine over cosine. So this is the function. Now what I'm going to do is I'm going to plug in negative x again, and that gives me 1 over cosine of negative x times sine of negative x over cosine of negative x. And now we need to determine if cosine and sine are odd. And if you don't remember this, it's pretty simple because the cosine, if you recall, looks like this. And if you're not sure, you can just start graphing it in your unit circle. It's symmetric about the y-axis. It's even. So what that means is, you know, for even functions, we have the property that f of negative x equals f of x. What that means is when I plug in the negative sign here, this goes positive. So this just becomes 1 over cosine of x. Now the sign is odd, which is the opposite. It means I can pull the sign out front because for odd functions, we know f of negative x equals negative f of x, right? So I can pull that sign out front, and I have negative sine of x. And once again, the cosine's even, so that the negative sign goes away. And if you don't know the sign is odd, you can graph it once again, and you'll find out that this thing is symmetric about the origin. Okay, so this just becomes then, if I rewrite this, rewrite it as negative sine of x, or actually, I'm sorry, I'm going to rewrite it as the way they have it written up here, which this is secant, so it'll be negative secant. I'm going to pull this negative sign out front. And then 1 over cosine is secant, and sine over cosine is tangent. So I get this, which is opposite the original function f of x, which must mean that this original thing is odd. I plugged in f of negative x, and I got negative the original function, which means that this thing's odd. Okay, next is solving quadratic equations, which is something you're probably pretty good at because you've done a lot of. But you need to have it in standard form first. We have 7x squared minus 3x plus 0 equals 0. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Now obviously this drops out, so I just get 9. And the square root of 9 is obviously 3. So I have, and this is 14 in the denominator. So I have 3 plus 3, which is 6 over 14. And I have 3 minus 3, which is 0. So 6 over 14 simplifies to 3/7. So 3/7 and 0 are my answers. And we're done. Let me try one more that's a little bit trickier. This one is actually a quadratic. It's kind of disguised because you got the square root and you have a first degree here. But it's still a quadratic pattern. In fact, what I can do is let x equal w squared. So let me make this w squared. That way, when I take the square root of x, I can take the square root of this side as well, and I get the square root of x is just w. So now I can rewrite this as x is w squared, square root of x is w, and now you can see that it's got the quadratic pattern a little easier. So let me solve this using the quadratic formula and then plug it back in to find my x's. So to solve this with the quadratic formula, opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. All right, so 4 times 9 is 36. 100 minus that would be 64. And that just gives me 8. So I have 18 over 2, which is 9. And I have 10 minus 8, which is 2 over 2, which is 1. So my two answers are 9 and 1. Now, those are my answers for w, keep in mind. I just solved this, so those are my answers for w. So if I plug those in here, you know, if I plug in 9 here, and I square both sides, I get x equals 81. And if I plug in 1 for w here and square both sides, I get x equals 1. So these are my two answers and not my answers for w. Okay, next topic is asymptotes. So for each function, we're going to find both the vertical and horizontal asymptotes if they exist. So for the first one, the exponent's the same in the top and the bottom, which means that the horizontal asymptote is a fraction of the leading coefficient, which in this case is y equals 1. And then the vertical asymptote always occur at zeros of the denominator, which in this case is x equals 3. So there's my vertical asymptote and horizontal asymptote. Now I have all this information summarized on the formula sheet. So let me pull that up real quick. We covered this way back in chapter 2. So vertical asymptotes always occur at zeros of the denominator, except factors that cancel, those are wholes. And then horizontal asymptotes, you have three possible scenarios. Exponent's the same in the numerator and denominator, which we just had. And you do a fraction of the leading coefficient. If the exponent's higher in the bottom, then the asymptote's y equals 0. If the exponent's higher in the top, then there's no asymptote, but there's an end behavior asymptote or a slant asymptote, which I don't think we're going to look at that right now. But we have these two different scenarios that we'll look at right now. So for the next one then, these are my horizontal and vertical. But for the next one, it's a little bit more complicated, so I'm going to have to factor this. I'm going to pull out a 2. Actually, I'm going to pull out a 2x from the top. That leaves me with x plus 3. And then in the bottom, I'm going to try to factor this. So I'm going to pull out an x. And left over, I have x squared minus 3x minus 4. Now I'm going to try to factor this. So I need to factor it into two linear factors. How about x minus 4 and x plus 1 will work? So let me put that right here. All right. So my horizontal asymptotes, the exponent is higher in the bottom than the top, so that means that y equals 0 is my horizontal asymptote. My vertical asymptote occurs at zeros in the denominator, but except for this one right here, 0, because that cancels. So that's actually a whole. So I'm not going to write x equals 0. That is not technically a vertical asymptote. But x equals 4 is, and so is x equals negative 1. Double check this by graphing if you want. But there's our horizontal and vertical asymptotes. Okay, next let's do some complex fractions. Let's simplify things like this. So to do this, we're going to need common denominators. So I'm going to need a common denominator of 4 here. So I'm going to multiply the top and bottom by x here. It's really 4 over 1. So I can multiply top and bottom by x. Same thing here. Multiply top and bottom by x down here. That way I can add these together. So I have 1 plus 4x all over x in the numerator. And then the denominator, I have 1 minus 2x all over x. A little hard to see, but now I can multiply by the reciprocal from the denominator. So I'm going to take the denominator, flip it, and move it to the top, like I've just done. And now the x's cancel, and I get 1 plus 4x all over 1 minus 2x. And there, I'm done. I can't simplify that anymore. Okay, let's try a more difficult one then here. So I'm going to need a common denominator once again. So I'm going to need to multiply the top and the bottom of this one by x minus 5. And I'm going to need to multiply the top and the bottom of this one by x plus 2. Okay, to save time, I'm going to pause it and rewrite the top now. And it becomes this right here, just the top. Now the bottom, I'm going to have to do the same thing, multiply the bottom by x squared minus 3x minus 10 to the top and bottom of this fraction 3 over 1. And so that's going to give me now in the bottom this right here. Now I'm going to simplify these actually first. So I'm going to distribute the 4 here, the 2 here, and I'm going to distribute the 3 to both of these and rewrite this right here. Okay, so just simplifying that, I get this right here. Now I'm going to add like terms together. So this 4x and this 2x are going to give me 6x, and then 8 and negative 10 are going to be negative 2. So this is going to give me 6x minus 2. And then down here, same thing. I have 3x squared. The 2x and the negative 9x make negative 7x. So I'm just going to change this to a negative 7. Get rid of this. And then I have minus 30. Okay, so now I've got this fraction here. Now what I'm going to do is move this to the top and multiply instead. So I'm going to flip this and multiply by x squared minus 3x minus 10 all over 3x squared minus 7x minus 30. So I just flipped this fraction and moved it to the top. Now, what you might suspect is that this cancels with this, and it does. So if you notice, whoops, this right here factors into x minus 5 times x plus 2. That's how we get the negative 10 and the negative 3. So, you know, this cancels with this then, and I'm left with 6x minus 2 over the denominator 3x squared minus 7x minus 30. And let's see if this simplifies at all anymore. I can factor a 2 out of the top. And I know it's a little sloppy, but this actually is the answer. This doesn't factor at all. The top you can factor by pulling out a 2 if you wanted to, and you'd end up with this. But the bottom doesn't factor into anything that helps us cancel. In fact, I don't think it factors at all. But there's your answer then. Okay, next is composite functions then. So we've got these three functions, f of x, g of x, and h of x, and we want to find the following. So let's do g of 2 and then f of 2. Now you work inside out here. So what it's saying is to take 2 and plug it into g, in which case g of 2, if we do that, gives us 2 times 2 is 4 minus 1 is 3. So now basically we simplified, that's f of 3 now because g of 2 is 3. So we've simplified this to f of 3. Now that means plug in 3 into f, in which case we get 3 squared, which is 9. So my answer is 9. All right, let's do it again now with this. So this is saying take 1/2, plug it into h. So if we plug in that, we'd have simplified to g of f of h of 1/2 now. If I plug in 1/2, that's 2 to the 1/2 power. So that's the square root of 2. Can write it as if we want. So I'm just going to write it as the square root of 2. Now I've simplified this because h of 1/2 is the square root of 2. So now we want to take square root of 2 and plug it into f. Square root of 2 plugged into f would just be right here the square root of 2 squared, which is just 2. So I've simplified it because f of square root of 2 is just 2. So then g of 2, just plug in 2 for g. 2 times 2 is 4, minus 1 is 3. So your answer is just 3. Okay, next is solving rational equations, equations with fractions in them. To do this, we're going to clear fractions always. So I'm going to multiply through by the least common denominator to clear fractions, which in this case is 6x. So determine the smallest thing that everything in the bottom goes into, which in this case is 6x, and then multiply through by everything in the top. Okay, when you do that, I'm going to show you my work here. So this would be 6x times this minus 6x times 5 over 6 equals 6x times 1 over x. Now things cancel and simplify, so 3 goes into this twice, so I end up with 4x. 6 cancels here, that's 5x, and then x cancels here, and that equals 6. So that gives me negative x equals 6, therefore x equals negative 6 is my answer to this one. Okay, one more then here. This first one I'm going to simplify. This is x plus 5. This is 1 over x minus 5. And this I'm going to factor. It's a difference of 2 squares, so I'm going to make it x minus 5, x plus 5. Now you can see that the least common denominator that everything in the bottom goes into is right here. So that's what I'm going to multiply through by. X minus 5, x plus 5. All right, now when I multiply, this cancels, so I get 2 times x minus 5. This x minus 5 cancels, and I just get positive x plus 5. And that equals, this whole bottom cancels, and I just get 16. So I can distribute the 2 from here. 2x minus 10 plus x plus 5 equals 16. And simplify this a little bit more. This is 3x minus 5 equals 16. Add 5 to both sides, I get 3x equals 21. So x equals 7. That's my answer. Make sure you double check that because you can get extraneous solutions whenever you have fractions here. But that should work.